So now that we have finished solving for numbers 6 through 9, let's take a look at numbers 10 and 11 to see how we can factor those, because those look a little bit different than the others. So here we have number 10. If we wanted to graph this by using our algebra tiles, we could use our x squared box, a 1x, a 1x, and another x. Over here we will have another 3 x's, and lastly we have our 2 positive 1 tiles. So this is our equation, x squared plus 6x plus 2 equals 0. So if we wanted to complete the square, we need to figure out what is filling this void right here. We need to figure out what that number is. So first off, let's get our x squared plus 6x, and let's move our 2 to the other side. Let's see how this would look graphically using our algebra tiles. Here we have our new graphical representation of x squared plus 6x equals negative 2. So let's try to see what we can do to find out what number of tiles will go into that missing area. When we think back to numbers 6 through 9 on how we solved the quadratic equation, we remember that we need to use the multiples of our b term so that we can solve for our c term. If we take a look at number 10, we see that the multiples for our b term won't work for solving for our c term. This is because the square is not complete. So, if we look at our multiples of our b term, which is 6, we can say we have multiples of 3, 2, 1, and 6. Now none of these will add up to 2. Thus, we need to figure out what is going to go here. This number will be the same amount of tiles that go here. Now to complete this square, if we drew in how many tiles would need to fill this square, we would get the number 9. There are going to be 9 tiles that need to fill this empty void space to complete the square. So we know that this number has to be a 9. Now you may be asking yourself, how can we figure out what this number is without having just to draw the picture and solve for it? Well, to do that, we know there are 3 x's here, there are 3 x's here, and 3 times 3 gives us 9. Now how can we do that using what we know? We know we have an x squared, we know we have a 6x, and we know we have a negative 2. So to get this number 9, we're going to use our 6. We take our 6, we divide it by 2, and we get 3. This 3 is the same number of how many x's we have on each side of our square. Now when we ask ourselves, how do we go from 3 to 9? We know we multiplied 3 by 3. And let's say we had 4 x's here and 4 x's here. That would mean we'd have to multiply 4 by 4. So the easy way to think of this is that we have to take this number and we have to square it. Thus, when we get 3 squared, that equals 9. 9 is the same amount of tiles that fills the void and completes our square. Now let's look at this without using our graphic tiles. We have our x squared, our 6x, and our negative 2. To find what goes here, we can use the formula b over 2 squared. Thus, we get 6 over 2 squared, which equals 3 squared, which equals 9. This 9 is going to go into this box. Now when we think back to the rules of our algebra, we know we can't just add 9 to one side and not do anything about it. What we must do to one side, we have to do to the other. Thus, we have to add 9 to the right-hand side of the equation. Since we have to add 9 to the other equation, this is what it will look like. Now, refining this, we get x squared plus 6x plus 9 equals 7, because 9 minus 2 is 7. Now we know when we added our plus 9 to the other side, we want to see how this looks graphically using our algebra tiles. This means we'll be adding 9 tiles over to these -2 tiles. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here are our 9 positive tiles, our 2 negative tiles, and our completed square on the left-hand side of our equation. Thus, once we reduce this down to our 7, this changes. This no longer has 2 rows of tiles. Instead, we just have our 7 positive tiles. 1, 2, 3, 4, 5, 6, and 7 tiles. So, what we can do from here is we can factor this, so we can solve for the quadratic equation. We know that this is 3, because 3 times 3 is 9, and 3 plus 3 is 6. That was simple solving for the quadratic equation. We know that from previous problems. Now what we want to do is solve. We know that this isn't equal to 0, so we know our answers aren't just -3. Thus, what we need to do is square root both sides, my apologies, and we get x plus 3 equals the square root of 7, positive or negative, because it is a square root. Finally, what we need to do is we need to get x by itself. Thus, we subtract 3 to the other side, and we get -3 plus or minus the square root of 7. Finally, we know it can be either one of these, so the first one can be our positive 7, 0, and our other version can be -3 minus the square root of 7, 0. And these will be our 2 final answers for solving this equation. Now that we have successfully completed number 10, let's move on to number 11 and see what's a little bit different of it. Number 11, we can see that we have x squared plus 6x minus 2 this time. We no longer have a positive 2. So let's see how will this work out using our graphic algebra tiles. From number 10, we move our -2 on over to the other side of the equation. So we have x squared plus 6x equals positive 2. We have our graphic tiles that we need to fill our void this time to complete the square. And we have our plus 2 tiles this time instead of having -2 tiles. So, to find this void, let's think back to how we did that on number 10. We know that this is 3, this was 3, and this is what we're trying to find. If we use the formula of our b over 2 squared, we know that we can take our 6 and plug that in to our b term. Thus we get 6 over 2 squared, which equals 3 squared, which is equal to 9. Now that we know that we have to add 9 to our equation, we can rewrite it down here. We have our x squared plus our 6x plus the 9 that will complete our square here equals our positive 2. And remember from number 10, when we add to the left, we must also add to the right. So we need to add 9 to our right hand side of our equation. Thus we add 9 tiles over here. 1, 2, 3, 4, 5, 6, 7, 8, and 9 tiles. We get x squared plus 6x plus 9 is equal to 11 this time, because we have 11 positive tiles right here. We know that we can factor this perfectly because this 9 perfectly fills in this square. So we have a perfect square. We completed it. Thus we can get x plus 3 squared is equal to 11. Now this is going to be exactly similar to number 10. First we must take the square root of both sides because we want to get rid of this squared. Thus we're left with x plus 3 is equal to the plus or minus square root of 11. Lastly, solving for x, we get x equals negative 3 plus or minus 11. If we want to solve this as a coordinate, we have our negative 3 plus the square root of 11, comma 0, and negative 3 minus the square root of 11, comma 0. Thus, we are completed. Using the completing the square method, we can solve any quadratic equation. This will help us solve one of the more complex ones, including fractions. This simple yet effective formula will help us in our long-term goals of solving quadratic equations in the future. Thank you for your time.